Thank you for joining the webcast today. My name is David Dingwall. And I work for the Business Development Department in Fox Technologies in the Europe and Asia Pacific market. I've been involved in implementations of IT security products of all types in some very large and challenging infrastructures around the world. This session in particular has been prompted both by a flurry of activity in my current customer base in Europe, who are in the middle of revising their second generation of tools in this space, but also some interesting new projects in Asia where change management stroke orchestration software is just about to be deployed for the first time. But first, let's talk about some survey results we've been pulling over the last 12 months. This set of statistics comes from a one-year worldwide survey we carried out with companies of all sizes, with server estates from a dozen or so machines to those with tens of thousands of nodes. Our responses have been garnered from Linux and Unix platform professionals themselves, rather than from executive management teams. And to be honest, we've teased and flavored this survey with weekly prize draws for Raspberry Pis and other tech goodies along the way. If you were one of the winners, then congratulations. And we'll talk a little bit later about the potential for winning some goodies if you come and visit us at some of the trade shows we have coming up. Back to the results. I think it's still pretty shocking that over 60% of Linux and Unix servers are still provisioning user accounts manually using adduser and changing passwords. You can see that just over 50% are using some kind of tooling and automation in three different categories: internally developed, third-party software, and freeware. And I think for the scope of this presentation, line 3 and line 4 are typically the products that we're looking at in this space. Change management and orchestration software that allows you to handle changes and push them into your Linux infrastructure. Lastly, you might see that the numbers on the right-hand side add up to more than 100%, meaning that inside your organization, there's still a strong chance that there isn't complete consistency in how accounts are provisioned using tools or using manual processes across the estate itself. And since we've been in this business for a long time, and many other vendors have also been in this business, it's still quite a challenge and quite a shock to see how inconsistent we all are. So let's have a look at how the world is building some new Linux infrastructures and how the tooling decisions made alongside them may affect your current practices. So I often get joked that my presentations are very focused on simple geometric shapes. So this time I'm trying to use 3 dimensions. And I'm using Lego as a metaphor through this presentation in many places. It's actually quite appropriate for some of the concepts that we're using here. They're very, very simple. Most of the attendees on this webinar are technologists of one kind or another, and you will have been involved in building infrastructures in a quite straightforward fashion. You'll be very familiar with the model that we're talking about here when you're building virtualized or blade computing systems. Each server block has one piece of software typically and a supporting operating system. Each server is discrete and separate. Network separation into a multi-tiered model is very easy to define. And the model in this picture is something that you see very commonly with web-focused and web-delivered environments. Load balancers at the front end, web servers in a DMZ with an LDAP database with customer account information to support the application, and then further into the infrastructure, various different application servers, either carrying out the same function or a mix of functions. And then at the back end, the corporate data in the corporate databases, and alongside those, the critical fulfillment services and interfaces to external parties, because you may not be fulfilling the customers that you're providing the service with. There may be links to other parties. For example, in the case of card payments, it allows an infrastructure designer to focus on, for example, the fulfillment services, size and scale, and prepare that part of the infrastructure to meet the SLAs, the robustness requirements, and the compliance needs to get certification without affecting the architecture and the other layers and nodes that you're designing. For this simple model, web scale services can be offered to the general public, in this case, to the single Lego figure on the left-hand side. Foxtees has been involved in the Linux and Unix security space for many, many years, actually decades. For the last 15 years, specifically in the enterprise market, IAM projects have been defined by security architects, both for consistency, in provisioning identity through the technical infrastructure, the operating system, applications, and other services, and providing clear links to session enforcement, either using internal tools or integrating with third-party enforcement mechanisms. In the early 2000s, the main driver for these IAM projects typically came from the IT department. More recently, HR, role-based management, and entitlement projects have pushed IAM models to be at least designed. I think it's honest to say that we've seen many, many ivory tower IAM projects sitting defined, waiting on the shelf of the CTO, the Chief Security Officer, and Vice Presidents of HR. There seems to be serious problems in getting a strong enough business case to take to a board, and it's been very, very difficult to sell to the individual lines of business as an additional cost without providing any benefit to the business. At the same time, with extreme business pressures over the last decade or so, something extraordinary has been happening in your data centers. IT operations management has been challenged to do much more with less. Both restrictions in headcount growth have been compounded by savage increases in net new server growth. Doubling or tripling your node count over the last 3 years is very, very possible. And there's also another trend we're seeing as customers and prospects are moving away from the traditional Unix vendors and migrating to what is called commodity Linux servers instead, where you may have a 2-to-1 to 5-to-1 ratio of nodes required to provide the same quality of service to the business. Greenfield sites are building and provisioning new web server estates, and these can grow from tiny clusters to tens of thousands of nodes within 1 or 2 years. Companies like Puppet, CF Engine, Ansible, SaltStack, and many others have prospered in that period. Originally focused on the node explosion in development environments, they have matured rapidly over the last 5 years. Many organizations are now using these tools, and they're now trusted in the development and QA environments, and they've been taken forward into productionizing high-scale cloud deployments vigorously. The functionality in these tools are quite similar. They allow you to capture the activities that your existing IT operations staff would carry out on a manual or scripted basis. They allow you to create recipes, modules, or scripts, depending on the terminology that comes from the vendor you're talking to create pockets of work that are reproducible on potentially every node in your infrastructure at the appropriate time to carry out a well-described change in operation or change in configuration. It allows you to have hands-free server provisioning environment from cold tin into a highly dynamic responsive infrastructure. And the funding for these vendors, these software vendors, has come in support from the major web companies out there like Google and Facebook. They've invested a lot of money, and these tools are being used to productionize their infrastructures, and you've been hearing from the market how big their infrastructures are. So I think we all are on the same page. We understand what these tools are. We all, I think, understand the capabilities of these change management and orchestration products, and we understand the sales messages. But this is a security-based presentation, so let me just step back a little bit and step to one side. At the end of last year, there was some interesting survey results that came from a number of organizations. And they all talked about the impact of penetration in your infrastructure and how that is promoted by a malicious insider or someone from outside getting into your infrastructure. FireEye came out, I think it was coincidentally the week after the Anthem exploit, and told us that the average time for penetration before you realize you've been penetrated was somewhere in the region of 30 days. So a malicious intruder is walking through your infrastructure and you know nothing about it for 4 weeks. That's quite a scary thought. But as IT professionals working in the Unix and Linux space, you also know that if you can get access to password and group files and shadow files, that it's not too difficult, even with desktop technology, if you have a copy of the Linux account password, to take it away and have a go at cracking it. It's been measured, you can crack a typical Linux password in somewhere between 2 hours and 2 or 3 days, and that could be done on site. If a malicious intruder has access to your infrastructure in one server and can promote themselves with privilege onto another, then you have all kinds of problems. If they're getting access to privileged accounts because they've broken passwords or they've broken pins and SSH keys, then you have all kinds of problems. You have no controls thereafter. The other problem is a fundamental one with SSH itself. The allowed keys file is exactly that, a file. And if someone has privilege to read it on server A and take it away and tear apart and exploit it, put it together in a different format to give them more privilege as they wander around your infrastructure, then there's not a lot you can do unless you have software on the server itself trapping and stopping you from copying the file or changing the file thereafter. And in many infrastructures, that kind of software is not in place. Normal security practices in Linux world, passwords are typically expired in a standard period, typically 28 days. For the case of SSH host keys, there's general recommendations that host keys should be destroyed and regenerated at least every 6 months. But we know from the surveys last year, and we touched on this in 3 SSH seminars last year, that up to 50% of Unix and Linux systems, SSH host key has never, ever been regenerated and replaced. That's an exploit waiting to happen the longer it stays on your system unchanged. What's interesting, that market requirements and compliance requirements to meet specific needs have added additional administration tasks for IT support staff. It's not just passwords that require life cycles. Any other credential in PCI 3 is now required to have a mandated life cycle and management track. So the SSH host key, the Kerberos identifier, the one-time password mechanism they're using, the certificates associated with any account, they all need to be managed. It's expanded in scope significantly. Also in PCI 3, there is a recommendation, although not mandated at this point, that the SSH host key must be regenerated on a much more frequent basis. based on the track record from changes in PCI in the past, probably by the time of PCI 4, this will be a mandatory requirement. But in practice, most organizations who are using PCI are just going through their first cycle of certification. They're just still changing the processes to make sure additional credentials are being managed and documented and controlled. But those life cycles for changes in those credentials haven't really started yet. Even more simply, the general recommendation to regenerate an SSH host key in a server every 6 months, that's still not happening, even after the surveys that happened last year. And it's definitely not happened yet for those organizations who are requiring host keys to be regenerated every 6 to 8 weeks. Now, NIST has come out with some recommendations along the same basis, and it's become obvious that changing keys is a real problem. And why? Because Linux administrators don't like messing with SSH host keys. So many other communications, batch transfers, automatic executions are all dependent on these keys being correct and properly established. And market data has come up with some metrics. It said it takes somewhere between 20 minutes and 2 hours per key change to ensure that production processes don't break as a result. And if you're running, say, 1,000 cluster in your infrastructure, and next week it becomes a 2,000 node cluster, then you have some real problems. The only way to attack these key changes and lifecycle processes is to have some kind of tool in place. That plays quite nicely into the sales messaging from change management and orchestration vendors. They have the ability to change objects, to change data, to change user accounts. And it does allow you to, that's just a small component of all the other things that the orchestration software carries out. You're provisioning the system itself, configuring the application, the user accounts and passwords and credentials are just a tiny piece of the puzzle for them. To carry out the correct sequences of events and make sure that happens is really part of their chaining. They have that under control. But the problem comes with some of the other credentials that are required. For example, SSH host key assignments may come automatically from the hypervisor itself. For example, Amazon does this. When you create a new virtual machine, the SSH host key is generated and provided to you by the Amazon infrastructure, not the orchestration software. What I'm trying to get you to think about, though, is the operational lifespan of a virtual server. If this is a dynamic environment in a virtualized infrastructure or blade-based environment, some of the machines, the gray Lego blocks, may come and go over time, escalated up to meet peak requirements and then turn back off again as minimum requirements, just keep the rest of the infrastructure going. But various layers of this Lego infrastructure have defined lifespans. A web server instance may only be up for a number of hours or days, so it may not be that important to have stronger security in place and watch management to detect changes in those accounts if that virtual machine is going to disappear after a few hours. An application environment might be slightly different. They may be recycled on a weekly basis. They may be refreshed on a periodic basis. So the attack window on an application server is a little bit longer, but maybe slightly less than a week. The machines further back into the infrastructure are turning more and more like traditional servers. They never go away. Databases and your core business data live in repositories that are, by definition, on nearly all the time. And the same kind of issues do tend to come up with systems that are used for external interfaces. It's not just state data inside your own environment. It's the queue of changes that are being sent off to other fulfillment centers outside your infrastructure. And that data needs to be tracked and maintained and held over time. And why am I laboring on about life cycles? Because the change management software typically doesn't play much of a part in deprovisioning. Deprovisioning dynamic servers is very, very easy to achieve. The virtualized off switch, say in Amazon or in Rackspace, is something that you see demonstrated very, very quickly. When you don't need a piece of infrastructure anymore, it just disappears. It doesn't very gently get powered down and deactivated, it just goes away. So there's very little to almost no interaction with the change management environment that created the changes in those systems while they were active. What we're left with, though, what I'd like to call the base load, never goes away, or at least stays there for long periods of time, getting into the weeks and months that make them look very, very much like traditional servers. So let's think about these change management products and what they're not so good at. Some of their behaviors are, by definition, replicating what an IT admin staff member would do manually. So if you create a credential, a key, a password, and that needs to be provisioned onto 1,000 servers, then it goes on to 1,000 servers. That's 1,000 change events being pushed by the orchestration software. And if one user account has 3 different credentials associated, then multiply that by 3. If there are links in association between servers in one direction or another with the keys, or attached to command execution, then there's more change events that need to be promoted. What's interesting to consider is also Sudo configuration files. Remember, earlier in the presentation, I talked about the assumption that a piece of Lego brick infrastructure is a standalone machine with its own operating system. So by definition, each Linux instance has its own Sudo file. And the change management system is handling and changing the Sudo configuration file on each of the 1,000 systems in this logical model. So I've used the Lego controller as the example here. It has a programming language where you update changes to the controller, and it then allows you to carry out different functions, almost in exactly the same way that changes in a Sudo file allows you to assume privilege and allows you to execute privileged commands as more privileged accounts. So the sheer amount of volume of change coming out of orchestration software into an existing Linux estate is quite top-heavy and often doesn't scale very well, especially when you're talking about concurrent handling of multiple key types. Also, by definition, this piece of change management software was never designed to do session control. If you have the right to SU to another account inside a single node, the change management software has no control there. The Linux operating system has very little control there itself. If you are SSHing from one system to another and assuming privilege along the way, the orchestration software has no control over it. Remember, you have not purchased an access management and control infrastructure with this software package. Again, I don't think I need to labor this much further. I think we all kind of get the point. Interestingly, though, in containerized models that we're thinking about for the future, for those of you who've worked in older Linux implementations like Solaris or HPUX or even AIX, this is quite well understood. Typically, there's a base operating system and it contains multiple containers of applications. Those applications could be fired up and spun down, but the operating system itself tends not to go away. And it makes your attack surface for various levels in your infrastructure grow significantly. The keys for the critical accounts in your base operating system need to be accessed and handled correctly. And because they're around for significantly longer periods of time, you seriously need to think about credential lifecycle management and pseudo control on these environments. Now, luckily, containerization hasn't moved very far from development in QA. People are still experimenting with it. But if you are thinking about containerizing your environment and using the existing processes inside a piece of orchestration software, yes, you can do everything you can do before, but you do have a data gap and a security gap to think about. In private clouds, we are seeing more pieces of infrastructure running Linux. There are a number of switch vendors who provide a Debian-based open networking infrastructure, and they provide additional commands to set up the fabric, set up the virtual switching, but the base operating system is Debian. It does not come with any additional security. There is no session management involved. The same with the Linux-based rack management tools that are starting to come on stream as part of the Open Compute model. So all the security models, all the security practices that in the past you had just focused on in the server space are now moving to other parts of your data center infrastructure. And the lifespan of these environments is measured in months and years. So you'd better get the lifecycle management sorted out. And again, that's something that the orchestration software is not very good at. The point I'm getting to here is your infrastructure is not as dynamic as you think it is. There are key components of your production infrastructure that never go away. They may move around to different nodes in your hypervisor infrastructure, but they're live for a large percentage of the time. And you need to think about the way you're going to handle keys and management for individual users, for host keys, and for the access management and privileged escalation through that infrastructure. Exactly the same as if it was physical machines in your own data center that are flashing lights in. Orchestration software is being sold quite extensively to carry out the same kind of functions you've been doing in your private clouds, but now in the public cloud space. And you can build the same kind of Lego infrastructures that you've done in the past. The big change is your view of your systems is encapsulated in a view that's tailored just for you. So your company systems are isolated from everybody else's. So the link out to the person in the general public through the load balancers may be through an internet connection, but you have a private connection, typically using SSH, to connect to your own infrastructure. What's interesting is the sales model for these environments have some kind of impacts that new customers tend not to think about. There's been a big push by the profitable cloud infrastructure companies to make it as easy as possible, and their sales message is to onboard as quickly as possible to make it very easy to migrate. And it allows you to pick applications, databases, and allow you to set up secure communications using tailored versions of SSL between applications and databases, between applications and web servers, and provide a secure and assured service to the end customer. The perception from some of these smaller companies moving to cloud infrastructures and continuing to use the orchestration that they already have or to take on a new piece of orchestration to handle the change management, there's a rather deceptive perception of the security model here. Interestingly, Bill Murray, the head of Amazon, was asked about a month ago at the big Amazon event in the US, what keeps him up at night? And he said, a very simple answer, what keeps me up at night is one of our customers gets hacked. He understands that there is a gap between what the sales, enablement, and the onboarding part of Amazon is saying, and what actually is true in practice, and has been true for as long as the cloud providers have been around, that security is a shared responsibility between the customer and the cloud vendor. The cloud vendor is just responsible for the security model from the hypervisor down through some of the private networking, through the storage, and some of the at-rest data and log environments that they provide. They provide security between applications and databases, for example, but they don't provide embedded security for the operating system that are part of each and every virtual machine that they have loaded. That is very much the customer's responsibility. And often, customers who are in the process of migrating now don't have strong security experience themselves. And the assumption is that they're picking the operating system and the application from the application page when you're setting all this up, then all of that's being taken care of. Bill's quite aware that that is not the case. And orchestration allows you to facilitate change, but it doesn't really help you so much with the underlying security aspects inside the operating system that you're sitting on top. And in most cases, in most of the cloud environments, apart from probably Microsoft, nearly every operating system that is established now is a Linux operating system. So where does FoxT come into the picture? I talked about some of the strengths and weaknesses of orchestration, what it can do for you, focusing on account management credentials. And there's a reason for that. Funnily enough, the same argument and discussions we've had with partners and vendors in the IAM space are almost exactly the same, that we control and reduce the number of change events that go into these infrastructures over time. And what do I mean by that? Say, for example, someone in your IT security team, for some reason, needs to log into a web server. And from that server, they need to open an SSH session into another machine in another layer of that infrastructure, assuming it's allowed. The public key to enable that session to be active, in the past with orchestration, would require that key to be shotgunned to that server in case it might be needed. With the FoxT infrastructure, at the point that the session is established, we will copy the public key onto the target server automatically. So if that key has been provisioned to server B, it may not have been provisioned to server C, D, E, F, or G. And that is very important when that credential is deleted and recycled and a new one is generated, because the pace of credential renewal is increasing. If you have 1,000 times 25 user accounts, and there are 3 credentials per user account, and all of those credentials have to be on each and every server just in case that support team member gets on there, then you have a lot of change events. If that key is only on 5 or 6 servers, because that's all the person has ever needed to connect to in that 6-month period or 6-week period, then the number of change events are significantly reduced. This allows you to scale your infrastructure significantly. The same thing is true for digital certificates. Over the last few years, it has looked like the support for digital certificates and SSH was diminishing almost to the point it was going to be end of life. But the NIST report at the end of last year has squashed that quite firmly. Digital certificates are back on the table for certain parts of your infrastructure. Having a credential that is not just trusted, but also has a chain of trust somewhere else that can be verified with OCSP or CRLs or something else is quite important. So in exactly the same way, we would provision the public key for a digital certificate on an appropriate server to enable, for example, an SSH session on an as-needed basis. We wouldn't push the public keys on every server in the infrastructure if it's never required. And lastly, we have a centralized pseudo infrastructure. So a major attack surface is the local copy of the pseudo file on those 1,000 machines. And the orchestration software doesn't let you change it or doesn't control the changes that you may make to it manually, either accidentally or maliciously. So it's something that we've taken control of centrally. It means you cannot modify privileged command execution in infrastructure that's protected by FoxT. And that's something that orchestration cannot do for you. Today was really all just about touching on some of the basic concepts and giving you something to think about. If you'd like to talk to us further, then by all means talk to us, contact us via the website. You have our contact information. Or if you are visiting some of the Linux events over the next few months, we'll be at Red Hat in Boston in June, and we will be at the Linux Foundation events later in the year in North America and in Europe. If you are in the middle of a project using orchestration or you are concerned about security, then please come and talk to us. We have customers with live infrastructures and also customers who are in the middle of their second and third iteration of orchestration. We have a lot of experience in this space, and we'd like to talk to you about some of your issues and concerns and where we might be able to help. Leverage the infrastructure you've already purchased, but fill in some of the security gaps that it doesn't even attempt to address. Thank you very much, and I hope the session has been useful for you, and we hope to hear from you soon.